My name is Ned McMahon. I was the founder, or am the founder of Malama Composites, and we did start out in the surf world. In 2005, there was a major event. Clark Foam, if anybody's familiar with surfing, closed their doors suddenly, left a big void in the polyurethane surf blank market. I had gone around the world as a shaper for about 15 to 20 years and got some calls to start a new blank company. But the technology for making surf blanks is very, very toxic. The whole surf industry is toxic. The chemistry is absorbed through your skin, doesn't matter if you wear a respirator or not. So we saw this as an opportunity to do something a little different, and we developed some plant-based technology. So I'll run through a bit of a PowerPoint on our company, and you can go from there. So we make polyurethane foam. We changed some of the chemistry out from petroleum products into plant-based products. From living in Hawaii for many, many years, Malama is a Hawaiian word that means to take care of or protect. The current technology, especially in surf blanks, uses TDI. The T in TDI is toluene. It's a carcinogen, can be absorbed through your skin. The B side of the process is petroleum, also produces a lot of VOCs. It's not recyclable. It's very dangerous, not only to the local environment, but very dangerous to the people working in the shop. And the off-gassing of the resulting foam is dangerous to the people that are working with it down the road. Our technology, we use an MDI, which is the safest isocyanate available, and we use the B side. We've replaced the petroleum product with plants. We've used different plants. We've used corn, sugar, soy, castor oil, a variety of things. We're looking at using algae oil right now. And in the true world of sustainability, we're really looking at not using materials that are part of the food chain and materials that are grown on marginal land with less water and such. In the process of developing the foam, the plant-based foam actually has really great properties. We have really high shear strengths, we have high compression, very good dimensional stability. One thing that's led to a lot of other projects that we've done is in a 72-hour water immersion test, there was no measurable water absorption. So there's a lot of benefits from a performance standpoint besides the environmental side. So our business by nature is a collaborative business because we're the core material in any composite. If you build a surfboard, you have a foam core with fiberglass and resin around it. If you do wind blades, it's a similar technology. If you're making housing panels, it's still foam as insulation. So EPS, PVC foams are sort of a competitor, and it's a huge market domestically, almost a $10 billion market. We recognized with only about 120,000 boards being built domestically, that we recognized from the beginning that we had to look at other industries. And construction was the largest industry that uses polyurethane foam. We make foam that's poured in a big block and it gets cut. And it's basically that same foam and cut into sheets that gets used in a house, in a wind blade, in a boat hull, a variety of things. So, you know, it's the same product. A lot of people have a hard time understanding that a composite is just a core material with some skins on it. So we saw a big opportunity to do some work in low-cost housing. There's a huge need globally, obviously. We've submitted proposals to places like Haiti to provide emergency shelter. We have a project right now going in Tijuana for 350 homes. We're working with a group to do some farm worker housing up in the Palma Valley. So the material is very lightweight. It's structural. Doesn't absorb water. Don't have mold issues. The common competitor is EPS in the construction world. We have twice the R value or insulating value of EPS. So it makes a really good product. And the cost savings in terms of construction, because you have a lightweight product, go down because things like the foundation can be smaller in the process. We also get huge lead points by using the materials. So what we're doing right now is building what's called structurally insulated panels. It's two skins, typically an oriented strand board or plywood, but the materials can virtually be anything. The example I have up here has more finished, sort of a melamine finish, and the thickness of the foam can vary too for whatever use that you want to have. You can make a low-cost wall that's only 2 inches thick, or you can make something that's super insulated, 6 inches thick. The SIP panels are used basically in every part of the house. It can be the roof, the walls, it can be a subfloor. And we've designed some structures that are, the Haiti deal, they wanted something between 250 and 300 feet. So these are low-cost things that are well insulated, secure homes, but you can also increase the panels that go together and easily build something bigger. Our focus to date has been things that are, you know, 1,000 square feet or less. And most of the stuff that we're really trying to do with it super insulated and both in the floors and the ceilings, it's more easily developed to build a zero net energy house because the insulation value, you have a reduced need for heat or air conditioning. With 12-volt wiring, instead of being connected to a grid, there's very efficient appliances and LED lighting. It would be really easy to have these small houses as zero net energy completely off grid. This is a basic shelter that was sent to the Haiti project. The other part of this, when we submitted our project to Haiti, they came back and said they were going to use cargo containers for emergency use, which sort of stunned me because, you know, who wants to live in a metal box in the tropics? Then they said, well, they're going to cut windows in them and insulate them. And I said, how much is that going to cost? And they said $100 per foot. Well, we can build our structures complete for about $30 a foot, and the emergency shelter is even less than that. So in our Haiti proposal, we sort of blew it, I guess, because we were thinking a little bit more longer term, and we thought the footprint of our plant is relatively small, and the CapEx to build a plant is pretty small, smaller than they wasted on the container project. But we wanted to put one of our plants in Haiti where they could build their own emergency shelters, then they could build bigger houses down the road, then they could have industry where they had their sheet foam that could go into other homes or other boat building projects or wind blade projects, and then they could even have a product where they could export it to the rest of the Caribbean, but they chose to go with the containers. So one thing with the housing too is that we've learned that you have to be culturally sensitive to the market. Our project in Mexico, for example, is in Mexico, the idea is that a concrete house is a good house. And they're building them out of concrete block and troweling some concrete on the outside so it looks like a good, strong house. But then they come back in and break all the concrete out to put the plumbing in and to put the wiring in and so on. And it's labor intensive and concrete's not that clean, although it's available all around the world. So what we did is we developed this product, lightweight. These are panels that get built in 8-foot by 20-foot sections. You wire them together, and then you put the wiring and concrete through, and wiring and plumbing through, and then you just put the concrete over it. So it is culturally sensitive to that concrete look and feel, but it's lightweight, super well insulated. The other thing that we're working on to take it a step further is I just got back from China, and while we're using primarily soy here, in China there's more availability for castor oil, and a lot of the castor oil comes from India. So we would be sensitive to the local materials. We've even started to look at, this is a part of a panel that we're working with another company on, and the wood that's the skin material is also, it's made from bagasse. This particular piece right here is made from wayuli. This gets, tons of it is burned every day. So we take the wayuli bagasse, we press it with non-formaldehyde clean glues, and now we have a panel that's really well insulated, structurally sound, doesn't off-gas, and is using throwaway materials. We've actually gone down in Mexico and used some of the agave from the tequila industry to make some panels. Again, material that is burned by the ton every day. So this is sort of the direction we're going, and I think there's a lot of opportunity to do some clean building, low-cost clean building. That's it. Thank you.